In 1918, the USS Cyclops became one of the Bermuda Triangle's most famous victims, disappearing without a trace off the coast of Barbados with over 300 men on board. Now, author Marvin Barish has brought me to the University of Miami's Sustain Lab, where we're about to test a theory that it wasn't the power of the triangle, but a naturally occurring rogue wave that may have sank the Cyclops. Lab director Dr. Brian House brings us down to the control room for the wind wave tank, with oceanographer Cedric Guigand on the ones and twos.
And so this is where the magic happens.
Yeah, this is where we create simulations.
One false button push here and it's a Category 5 hurricane?
Yeah, look out, it's all over.
Wow, amazing.
The wave tank holds over 30,000 gallons of water, and the turbofans are capable of generating winds of up to 155 miles an hour.
And Josh, we've got a little surprise for you today. This is the scale model of the Cyclops that we'll be testing.
Oh my word, this is incredible.
This is custom built based on the design schematics of the Cyclops.
Wow.
This is an exact replica built to 1/267th scale. It has a functioning cargo hold and matches the original in every eccentric way.
The detail on this is amazing. We even have tiny crew members here. This is unbelievable. And look, right out of the gate, even before we put this in the water, you know, getting back to its unique look, it is really peculiar. I mean, it has this extremely flat bottom. It also just has the appearance of something that is naturally kind of top-heavy.
Yeah, it's very tall and narrow.
So this is going in the tank?
She's not the only thing going in. We got to get in there with it.
We're going in?
We're going in.
Oh, I did not pack a bathing suit.
That's unfortunate.
Marvin will stay with Cedric to monitor the testing, while I roll up my pants and climb into the wave tank with Dr. House.
Could have warmed this up a little bit, Doc. Good Lord. Okay, so model's going in. All right, so she floats. That's a good sign.
Our model Cyclops is remote controlled. I start her up and send her off into our simulated ocean.
Hey, Josh, let's try to keep it steered into the waves.
You got it. My first time piloting an early 1900s coal steamer. Looks pretty good, actually, yeah?
Yeah, it looks pretty good. It's riding all right.
Marvin, can you see the boat in here?
Yeah, she looks pretty good. Yeah, she's taking the waves pretty well.
I used to have a toy boat in my bathtub when I was a kid. This is better.
Now you have to take into consideration she was carrying that dense manganese ore.
Right, okay, let's see how she does when she's more weighted down.
Since Marvin's chunk of manganese won't fit, we have lead weights to simulate the load the Cyclops carried on her final voyage.
Okay, Josh, you can take the whole top of the deck off. And we can put this ore evenly distributed in here.
Okay, so that's our manganese ore. We have our heavier payload in there. So we can see that she's sitting much lower in the water now. Not surprising, she's more weighted down.
Cedric, let's go ahead and
Start the waves.
Okay, starting.
The floor beneath us vibrates, and I feel the water begin to churn. Soon, the wave tank earns its name.
Here they come.
Okay, here we go, waves are coming.
With the ship's cargo hold loaded with substitute manganese, she again speeds off into the waves, but it's no longer smooth sailing.
Ooh, she does not look happy. Still up, but I feel like if I don't keep her pointed into the waves, it's gonna be over.
Yeah, you definitely have to be more careful with the steering in this one.
Even with just the manganese ore on board, she's so much harder to control.
Now, this is a 1/267 scale boat, so your waves that are a few inches high here are really like about something on the order of a 30-foot ocean wave.
Wow.
Pretty rough seas. It certainly wouldn't be any fun to be out on.
So serious seas, and she's doing okay.
Yeah, still doing okay.
Fully laden, the ship is sluggish, but the mini Cyclops has proven capable of handling some rough seas. I pull our model out of the water so the team can prep the wave tank for the ultimate test, a simulated rogue wave.
Now let's talk about a rogue wave. How do we figure out the general size of a rogue wave?
Well, kind of a general rule of thumb is the rogue wave is twice the significant wave height. So for those 30-footers, would be something over 60 foot.
Okay, so can we generate a single rogue wave of that height?
So what we can do is kind of like the way rogue waves can form actually on the open ocean, which is we'll generate a group of waves, that are moving at different speeds. And the faster ones will catch up with the slower ones and create one suddenly large wave that kind of comes out of nowhere.
And so they'll build up as they come down the tank and form into a large wave here?
Right, and to make it more realistic, we're going to need some wind on it.
Okay, let's get some wind.
Okay, Cedric, let's get some wind in here about 30 miles an hour.
Stand by.
All right, hold on to something.
With the flip of a switch, conditions in the tank go from a lovely day on the ocean to better call in the Coast Guard.
All right, well, we got wind. Now, we need a wave.
Cedric, let's turn on the rogue wave.
Okay, ready for the rogue wave.
Here they come.
Oh, boy. Okay, here we go. Little waves building up. Oh, they're merging. Here we go. Big wave. Okay, going straight ahead, straight ahead, straight ahead. Here we go.
The wave rushes toward the ship. We're about to find out if the USS Cyclops could have survived a rogue wave.
Here they come.
Oh, boy. Okay, here we go.
In the wind wave tank at the University of Miami, researcher Dr. Brian House and I are attempting to test the theory that a rogue wave in the Bermuda Triangle was responsible for the disappearance of the USS Cyclops. Our model ship has held up to the waves thus far, but now it's about to meet a rogue wave for the first time.
She's down!
Our model Cyclops is lost to the depths. The heavy cargo, combined with the narrow, ungainly design of the ship, is no match for the realities of a rogue wave. And there are historic clues that our experiment demonstrates the true fate of the Cyclops. Of her three sister ships, two of them, the Proteus and the Nereus, were also lost at sea without a trace, suggesting that the design of this class of ship was likely fatally flawed.
Look, I don't think you need a supernatural Bermuda Triangle to take this ship down. I think there's every chance that she sank just as she did here because she was unstable.
Yes, it all adds up, and
It makes a lot of sense.
All right, well, thank you very much. I really appreciate it. Let's get out of here and get dry.
It turns out that the disappearance of the Cyclops, a ship which has long served as an emblem for the power of the Bermuda Triangle, may be owed to entirely explainable, albeit tragic, circumstances. Having said that, it must be conceded that no trace of the Cyclops